Hello and welcome to the Titus Timeout podcast. I'm Jenny Civey, and today we're going to talk about how to determine the downward throw from catalog diffuser data. Instead of me trying to draw the downward vertical projection graph, we're just going to use the one from the Titus engineering guidelines. The downward vertical projection diagram is one of the most useful diagrams in the Titus catalog because catalog data are always taken in isothermal conditions, basically 75-degree supply air in a 75-degree space, but diffusers are usually used in heating or cooling mode. Using this diagram and the diffuser performance, you can estimate the cooling and heating throw of a diffuser. If you know that the cataloged vertical throw of a TMSA, for instance, is 12 feet, then you can follow that row over and see that with a 20-degree delta cooling supply air, essentially 55-degree air, the diffuser will have a 16 to 17 foot downward throw. With the 20-degree delta in heating, essentially 95-degree supply air, it'll have a 7-foot downward throw. One thing to notice is that making the air hotter, say a 40-degree delta T or 115-degree supply air, shortens the throw to only 5 feet. The hotter the air, the harder it is to get it into the occupied zone. This is why ASHRAE recommends no greater than a 15-degree delta T for heating. Every now and then we see a VAV box selected at a really high discharge temperature, say 130 degrees. So using this chart, you can see that the throw would be less than 5 feet, maybe it's 3 feet, and it's going to be much harder to get the heat into the occupied zone. We'll cover heating, specifically perimeter heating, in a future podcast. So now you know how to get downward throw from catalog data. Thanks for taking a time out with us.